Hi everyone, myself Dinesh, working as assistant professor from the Department of Mechanical Engineering, SNS College of Technology. Okay, so in a previous video, we seen the core components of FMS. Okay, that means we have seen the four main components. So now we are going to see the empathy of this uh, components in FMS. Okay, so to understand a point of conventional manufacturing system. Okay, so manual material movement. So workers physical transport heavy part between stations cause uh, safety risk, right? So if you physically transport heavy materials or parts from one place to another, will lead to severe accident factors. It also time consuming. Okay, so this is also one of the major reason, and followed by machine ideal time. Okay, so equipment sits unused, waiting for material or instruction, which are probably a wasting time or wasting capacity of that particular machine. Okay, so that's the second point. And the third one is production delay. So scheduling conflicts and coordination failure lead to missed deadlines. Okay, so these are the main empathy of this topic. Why we are concentrating more on FMS. Okay, so the first one is manual material movement, and then machine ideal time, and then production delay. Okay, so now let's take a real world scenario. In traditional machining shops, operators spend up to 30% of the shift manually carrying part between machines. Okay, creating bottleneck, physical strain, and inconsistent cycle timing. Okay, so this is the real world scenario. Okay, now let's go for a quick check. Okay, which issue is most common in manual material handling? Okay, so the answer is also given here. The options are high speed, zero fatigue, production delay, and full automation. Okay, so obviously the answer will be production delay. So now define. Okay, so this is the second part, and of FMS components. So the problem statement is, how can we integrate workstation and material handling to minimize idle time and maximize production flexibility? Okay, so the core challenge. Okay, first, in order to study or undergo any specific topics, the main thing we have to understand is the core challenge. Okay, so it's very much important when it's come to any subject or any particular topics. Okay, so traditional manufacturing suffers from disconnected operations. Okay, each workstation operates in isolation, creating coordinate gaps between the waste time, and requires system level thinking, viewing workstation and material flow as an integrated network rather than separate element. Okay, so when we are going independently between the departments, and when we integrate those departments, we can see the difference. Okay, so integration lead to achieve a result within the prescribed time with more efficiency. Okay, so the real-time example, a precision CNC machine center capable of producing 120 parts per hour sit ideal for 15 minutes every cycle because material delivery is unpredictable and reducing actual output to just 80 parts per hour. Okay, so this is what happens when we go without integrating the stations. Okay, so which lead to the ideal of machines which is more capable of producing more products. Okay, so this is what the problem statement is. Okay, so how we integrate workstation and material handling to minimize ideal time. Okay, the first thing you have to understand very much is I to minimize the idle time and maximize the uh, production flexibility. Thank you.